All right, brief video, introduction to logistic regression in 5 minutes. What is logistic regression? Okay, again, this is just an introductory talk, but it's a statistical model that is used to estimate the association between a binary outcome and one or more predictor variables. The predictor variable itself or themselves can be binary, continuous, doesn't matter. And the output of the logistic regression model, most often, it's an odds ratio. And this odds ratio tells you the strength of the association between your predictor and the outcome of interest. A quick reminder, if your outcome is continuous, then often you'd use linear regression. Let's give a basic example. Maybe your research question is whether or not sex is associated with a heart attack. So the outcome here is heart attack, yes or no, and the predictor variable is male or female. So first step, to get regression results, first you got to collect some data. So let's just pretend we have 10 patients worth of data, 5 women and 1 had a heart attack, 5 men and 2 had a heart attack. The next step is you would then run logistic regression on your data set. You can use a programming language like SAS, R, Stata, Python. Heck, even ChatGPT can do logistic regression. This is what your table would look like. So you see one column for each patient, one column for their sex, and one column for if they had a heart attack or not. Okay, so there's one of the men who had a heart attack, another man who had a heart attack, and then the one woman who had the heart attack in this very made-up data set. And then here what I did was, because it's so straightforward, you can just ask ChatGPT to run the regression results for you. And again, we're doing this because our research question is, hey, how is male sex or female sex associated with the risk of heart attack? So one way that this can be done is you can just calculate an odds ratio from a 2x2 table. If you're like, what's a 2x2 table? Watch another video on that. And very quickly you can calculate the odds ratio and it comes out to being 2.67. You can pause the screen if you want to see the math, but it's right there. And then similarly, you can just ask ChatGPT, hey, can you run logistic regression on this fake data set? And as you see, the odds ratio here is 2.67. Will the odds ratio you get from a 2x2 table always be the exact same as from a logistic regression model? Not necessarily, but in the scenario where you only have one single predictor, often you'll get similar results using both approaches. So the way that you would report these results is that men have a 2.7-fold higher odds of heart attack compared to women. Now, if there were multiple variables, then we would call this multivariable regression. And let's say you also had age and smoking and you adjusted for those factors. Then how would you report the results? You would say, after adjusting for age, smoking, the odds of a heart attack was 2.7-fold higher for men compared to women. And if you're like, oh, so it's the exact same result even after we adjust for other things? No, this is just a toy example. So often after you've added additional variables to your model, the odds ratio for this key predictor of interest will most often change. You can also use logistic regression to estimate probability. And probability is just success divided by all possible outcomes. And one of the most common reasons why you might want to calculate a probability from a logistic regression results is to calculate a propensity score. A propensity score is just a probability, and we have a whole other video all on a crash course on propensity scores, which will either appear in this slide or the next slide. There are a few important assumptions of logistic regression. So first off, you're assuming your outcome is binary. Each observation should be independent of one another. What do you mean by that? Okay, so in that fake study of people with a heart attack, if one person has a heart attack, that won't necessarily influence some other person in your study's risk of heart attack. So we can say that those outcomes are independent of one another. If instead the primary outcome was COVID-19, Well, those outcomes are not independent because if one person gets COVID and they're in the same room as another patient, then they might get it as well. So that's an example of where outcome might not be independent. And then finally, and most complex, there's a linear relationship between the predictor variables and the log odds of the outcome. I appreciate that's confusing, but this is just an introductory talk.